Okay, let's take a look at the warm-up for today. We got solve system using reduced row echelon form. So in other words, this is using your matrix and your calculator to get this set up and solved. So first thing we check is these do need to be in standard form. So x, y, z, then a number, x, y, z, then a number, x, y, z, then a number. So all three of these are already in standard form, so you don't got to do any moving around. So I'm just going to go ahead and write it in a matrix form so I know exactly what I'm going to be putting in my calculator. So remember, you just take your coefficients here. Pay attention if they're negative, though. Like that does have to be a -3. 4, 2, -6, 0. 1, -1, 1, 0. So obviously, number's not in front. We know that's a 1. We know that's a -1. Zeros are just zeros. So the numbers that you put in here are very important. They have to match exactly. You can put your little dashed line here if you want to make it a augmented matrix. You don't have to. All right, so now that we're there, we're ready to jump to our calculator and put it in. So you can also use the matrix app that's up at the top of the classwork, but that's up to you. So anyway, matrix menu, over to edit. And this is a 3 rows by 4 columns. So 3 by 4. And then we just type these in. So carefully get everything entered. You should be able to just press enter as you're doing it. And looking good. So I always kind of recommend double check, take a look at it, make sure that everything looks correct. Because if you put anything in wrong here, obviously your answer is going to be wrong, but it looks good. So we quit out of it, back to the matrix menu, over to math, and pick this RREF. That stands for reduced row echelon form. In other words, it's going to reduce this all down to solved form. Okay, and then matrix again. So you're saying do reduced row echelon form to matrix A, the one that we just created. Press enter, and it gives our answers here. Now you notice this one happens to have some decimal answers, which is completely fine. So the way you read this is actually, sorry, I gave this on purpose. So this looks like, okay, we have, if we arrow over, we can see what we've got here. What we actually run into is we don't have diagonal ones. So at first you're like, okay, yep, X, Y, but notice the Z, there is no 1 there. And if you look at your bottom row, it's actually all zeros. We've talked about this before. So I don't really care what those top 2 rows are. They don't really matter. I could write them down if I really wanted to. What's really important in this problem is that you recognize that that bottom row is all zeros. And whenever you see that, if you remember we wrote it in our notes, this means that this has infinite solutions. So this graph has an infinite number of solutions. We could specifically say what they are, but we're not super concerned about that right now. This is kind of the big idea. Now, the other possibility that can happen here, so this problem didn't do this, but it's also possible you can get some stuff on the top 2 rows, and then you get all zeros, but then there's a number over here, like a 4. If this happens and you see that 0 is equal to 4, that obviously is not true. This has no solutions. So if you ever see this happen, that's your other possibility. But obviously, in our case, our problem ended up having all zeros on the bottom, so it's an infinite solutions.